Okay guys, hello everyone. Let's discuss a very interesting problem from GFG, reorder linked list or list whatever. Okay, so we are given a linked list A0, A1, AN minus 1 whatever, and we have to rearrange it such that the last element that was initial that is AN should point to the first element. Should be the next or first element, and the second element should point to the second last element, and the third element should point to third last, and so on. Like for example, if we are given this 1 5 2 3 4, so the first should point to 5, second should point to 4, and the third is even it's point to null basically. So this should be my linked list. So yeah, let's discuss how to do this question. Okay, so here is my linked list. I've taken this linked list for the following example. Okay, so the first approach that comes to my mind was, suppose this is the head pointer and I've taken an iterator as well. Here an iterator. Okay, and what I'm going to do is, actually I'm gonna take a temporary pointer also here as well. Yeah, what I will do is I will move this temporary pointer up to the last one by one. Yeah, from here to here to so on, such that it reaches this point. Okay, now as my iterator is reached to the end, and my temporary dist pointer is on the one, so what I will do is I will point my t's next to it, t's next pointer to it, such that this node would point to this one now. Okay, so basically this link would be removed. Yeah, and while iterating I will take a previous pointer as well, like which would initially be null. So suppose my previous pointer is here, and I will basically do the previous next null to break this link as well. Okay, yeah, so I break this link as well. So my node actually, now to be a little simpler, my node actually becomes, yeah, something like this. My node becomes something like this, and my IT is still on this one. So my temporary was on this point basically. So what I will do it, I will, like, before changing this link I would increment it to this as well, and such that, and after that I will do IT is next to T. Okay, to maintain their links as well. Okay, so after the first iteration my node becomes 1 8 2 3 4 5 6 7. Okay, so again initially, now again I will start my IT from here, and I will basically move it to the last, that is to the 7, and my previous pointer would come on 6 in this case, not here. So yeah, and as my temp is on the 2, what I will do is I will point my temps next to 7, and I will wait, let me change this link. Yeah, I will point my temp, or T is next, not temp, T is next to 7, and I will basically previous next to do previous next to null, so that this link is now removed. And yeah, and I will point this link also here, and yeah, IT is next to T, as my IT was here, not here, sorry, IT is next to T, so this link is also made, and yeah, I will break this link as well. Actually this link would automatically break when I will point T is next to IT, so this link would break. So yeah, now after this second iteration I can say my list becomes 1 8 2 7 3. So yeah, let's go for the third iteration as well. After the third iterations, my IT would be here, my previous would be on 5, so similarly in T would be here, obviously T. After the second iteration my T would be here, so again similarly my first step was T's next would point to IT, this is IT, okay. T's next would point to IT, so IT was 6, so T's next should point to 6 now, so this link would be vanished, okay. And IT was here, so T's would point to now 6, and yeah, my previous next would become null. This was my second step, so I will break this link as well from here. Okay, previous would point to null now, and my IT would point, I will basically bring this T here also, and I will point my IT is next to T, so this link would be made. So yeah, after this whole iterations my linked list would become to be more specific. Yeah, so my linked list would become something like 18273 18273 and 18273 6 4 and 5 6 4 and 4, sorry, and then 5. So yeah, okay, pretty simple I guess, but yeah, obviously like you must have observed, like I am traversing IT many times, so basically the overall complexity of this approach is of n square. However, we are not using any extra space besides creating the linked list, but yeah, the space complexity is not the issue, the time complexity is the issue here. Can we can we optimize it a little bit? Okay, so let me kind of optimize this using my second approach. So yeah, this was my linked list. So like in the previous approach, we were traversing again and again every linked list. We were basically bringing the IT iterator to the last again and again, and we were pointing the startings, or you can say the temp to head to the last one and so on. So why can't we just store the addresses of every node so that it's easy to access? Basically we don't have to travel again and again to the last. We can just directly access the address from here. Like I'm making the vector, or the array vector would be suitable, so I'm making vector of node star, basically you can say, because that would be very easy to traverse. So again that same trick I am using. Head my pointer was here, my temp was here, and IT, basically IT would be now on this vector. Okay, no, actually no need for taking IT as well. Wait, let me show you how you can traverse it. So I will point my temp to the last node, so I have directly access of the address. So basically this is the address. I am just showing the values here, but this is the actually address of 8th node. So directly from the vector I can make T is next to the 8. So again that same approach, T is next to the 8. Okay, so I'm moving T to the 2. Okay, so I can now move the 8's next to T. Okay, simple. So after that I can access. Okay, so 8, the work of 8 is done, fine. So after that I can access T directly. I have to point T to the 7, so directly from here I can point T to 7. And wait a second, I should remove this also. Okay, so yeah, I can directly, and this one as well. So directly I can access 7 from this here, and directly I can make this link here, and I will make T here, and I will remove this link. Wait a second, and I can directly point 7 to 3. Simple. This is the same approach as the previous one, just we are kind of storing the values or addresses actually of all the nodes in a vector, and we can directly access it in O of 1 time. So its complexity is reduced to O of n rather than O of n square, or you can say so. Rather than O of n square, now we are solving this problem in O of n. But here the space complexity is increased. The time and space, both the complexities are now the O of n. But in previous one, the space complexity was O of 1. So first let us see the implementation of this vector approach, and after that I will explain a third method as well that is a little optimized and it is better than these two. Okay, so let us move to the implementation part. Okay, yeah, so let us look at the implementation of approach 2. So yeah, we have to complete this function. As I told that I would take vector and a with of struct node type, and I would basically store the addresses of all the nodes or the linked lists into this vector. Okay, so I'm taking L as V size, and I'm initializing P again with head. So what I'm going to do is I'm going to basically iterate up to the length L by 2, and I will basically consider my previous example 1 2 3 4 5 6 7 8. So 1 should point to 8, and 8 is on the last index, so I will use L minus I minus 1. P's next should point to that last index, and P should move to now 8. Okay, so after that I know my I would be incremented to 1, and on 1 I have the address of second node. So obviously I would point P's next to VI. VI means V1 here. So yeah, 1 to 8, then 8 to 2, then I would increment P to 2, then obviously I would now access to 7, which is in the L minus I minus 1. So P is next to point to L minus I minus 1. So yeah, this is the perfect loop working here. So this loop would basically change my links, and after that actually we have an special case. Suppose my length is odd, obviously this loop would travel for even number of times. If suppose my length is odd, I would be left with one you can say one node that is untouched. So for that I would basically point P's next to VI. I would means that middlemost, you can say the middlemost, it would obviously my middlemost node, and obviously my middlemost node's next would be null, so I would basically make P's next to null. And yeah, I think that was also a very simple case. So as I told you before also, the time complexity for this function is O of n, and space is also O of n because we are storing all the node values into the vector. Okay, I hope this approach is clear. Okay guys, so let us now discuss the third approach for this question, and this is the quite optimized approach, you can say. And this approach is I will explain you. I will use the formula for Floyd's algorithm, you can say, using Floyd's algo. So let me go through the brief to what was that Floyd cycle algo basically. So for explaining this, I am taking the example of two runners A and B. Suppose this is some distance D they have to cover, and A runner, I am assuming that it would run with the speed 2s, and B runner would run with the speed s. So as we know that distance is directly proportional to speed, so A would cover twice the distance at the same moment B would cover half the distance to the A. So suppose when A has reached here, so obviously B would be at the middle one, because B is running, A is running, you can say, at a speed twice that of A. So distance covered would also be twice. So obviously in that case B would cover half the distance of A. So in the linked list also I can use this algorithm. I can basically take two pointers F and S. I can you can say increase, or I can make F pointer to jump 2 steps and S pointer to make a jump to 1 step, such that when F is reached to the end, S would be at the middlemost element so of the linked list. So when F is at the middlemost element of the linked list, I will break the linked list in two parts, such that and then I will connect the links. So let us move to the let me show how I can do this. Suppose I have taken this linked list. Okay, so this is my linked list, and again I am using that algo F and S. So I am incrementing F to 2 steps, so it means F would move to 3, and my S to 1, so 1 step, so S would be here. And let me remove F and S from here. Okay, so again F would be incremented to 2 steps, so it would be on 5, and my S would be incremented to 1 step, so it would be on 3. Let me remove their old positions. So yeah, as we can say that F has reached to end, so its next is null, so we would stop here. S is on 3. Okay, S is on 3. We would stop here, and basically I would divide this linked list to 2 parts from here. One linked list would be my 1, 2 and 3, and second linked list would be 4 to 5. Okay, till now I have only traversed once to this linked list, so the time, you can say the time complexity is of 1, and spaces I have not used any extra space. So till now I have of 1 space and of n time. Okay, so what I'm going to do is I'm going to basically reverse this linked list. So I am assuming that you all must be knowing the algorithm to reverse this linked list, so I'm not getting too much detail. So yeah, after this, the linked list, we have 2 linked lists, this, and I'm bringing the S pointer here. Okay, basically I will break this linked list by making S next to null. So first of all I will bring fast to the X next, and to the S fast would be S next, and after that I will make S next to null, and I will bring S to head, so I will get these 2 linked lists. Okay, so now let us do the same thing again. I would interchange the connections. Let me move to the next page. Okay, so these were my 2 linked lists. My S was here, my F was here. Fine. So I am taking 2 temporary pointers as well, T1 and T2. I will explain their role as well. First of all I would basically point S next to F. Okay, actually not F next, I would point T1's next to F, and I would actually increment this to here, and T1 would be S, so T1's next would point to F now. Okay, so this link would be broken, you can say. Okay, so I would increment F to 4, and I would rub it from here, and initialize T2 with F before moving F to 4. Okay, now what I will do is I will make T2's next to S, so I would remove this link, T2's next to S, so it would point to S now. Okay, simple. So again the same step repeating, I would initialize T1 with S, T1 would be here, and I would increment S to 3. I would increment S to 3. I would point T1's next to F. T1's next to F. Okay. Now as we can see that F's next is null. F next is null, so F is removed. Okay. So before you can say before moving F to null, I would initialize T2 to F. So T2 would be here. Okay. Removing this from here. So, and I will point T2's next to S. T2's next to S, and I will increment S, so they would become null. So yeah, my linked list is finished. So after that I will get simply 1, 5, 2, 4 and 3. So yeah, I got the answer, required answer. I think that was pretty much simple approach, and besides this we were not using any extra space, and the time complexity is also my friend. And remember that while reversing the linked list also we are taking the time of n only, and the space no extra space. So yeah, this method is using the time complexity of O of n and space complexity O of 1. So I guess this is the most optimized or perfect method for this approach. And that was a little simple as well. We were using the concept of Floyd cycle to basically break two linked lists from the middle part, and then we were reversing the second linked list, and then we were just changing the links like you have seen 1 to 5, 2 to 4 and whatever. And that was also pretty much simple, I guess. I hope this approach was clear, and let us now move to the implementation part of this approach as well. Okay, so this is the implementation part for this problem. I hope it is feasible. Yeah, so we have to complete this reorder list function only in the GFG. So as I told you, we were using the Floyd's method in the, so for this Floyd method I am taking two pointers F and S. I am incrementing F 2 times, so basically F assigns to F next, and S next is assigned to S. Okay, so yeah, after that I will basically get S pointer to the middlemost one. So I will break the two linked lists by making F point to S next and S next. After that I will make S next to null and S to add, so that I will get two linked lists. So again I've told you reverse list would take O of n time. So yeah, this is the recursive function that I've written for this reverse list part. And yeah, after that I am getting two lists. The first one is the reversed one, and the S is the basically the first half of the original one. Okay, so after that what I am going to do is I am just interchanging the links. As I told you, I was taking T1 point to S, and after that I moved S to the next, and then I was basically pointing T1's next to F. Okay, so again after that T2 I was pointing to F, again I was incrementing F, and T2 is next to S. So that was a same thing that I explained. That was a simple, I guess, simple approach, but a little bit tricky one. So I hope this approach is clear, and yeah, thank you so much guys.